think about this for a second. A jellyfish has no bones, no fins, and no brain to speak of. And yet it moves through the ocean with this quiet, effortless grace. So how does it actually work? A jellyfish is basically a bell, like an umbrella that can squeeze and relax. When it squeezes the bell, it shoots a pulse of water out from underneath. And that jet of water pushes the jellyfish in the opposite direction, upward or forward depending on the angle of the bell. Then the bell relaxes, refills with water, and squeezes again. This mechanism of movement is called jet propulsion. Now let's take a peek inside the bell, because that's where the real story is. Most of the bell is made up of mesoglea, which is basically a thick jelly-like material sitting between the outer and inner layers of the body. And on the inner surface of the bell, the underside, which we call the subumbrella, there's a ring of muscle fibers called coronal muscles. When those muscles contract, they pull the bell inward. The cavity shrinks and water gets forced out underneath. That's the power stroke, the part that actually costs the jellyfish energy. Now here's where it gets interesting. When those coronal muscles relax, they don't push the bell back open. It's the mesoglea that does. It's elastic, almost like a compressed spring. During the squeeze, it was quietly storing mechanical energy. When the muscles let go, the mesoglea releases that stored energy and springs the bell back to its resting shape, all on its own. The bell reopens passively. No extra muscle effort, no extra energy spent. Water flows back in from the sides, and the bell is already primed for the next stroke. Now, jellyfish aren't perfectly steerable. They can't do sharp turns like a fish, but they're not drifting at the mercy of the current either. The angle and symmetry of the bell can bias which direction the jet pushes, and many species use this to maintain their vertical position in the water, moving toward or away from the surface to follow food or avoid predators. The movement of a jellyfish is not precision navigation, but it is genuinely directed movement, making it one of the most efficient locomotion systems of the ocean.